Hi, my name is Victor and we are discovering the DFT, the Discrete Fourier Transform. But first we need to discover what signals are. And we need to differentiate between continuous signals and discrete signals. And then we need to talk about frequencies. So, let's go! Our world is continuous, which means we can divide time finer and finer and we will never come across any limit. So, for example, for any signal, like the periodically changing air pressure coming from a speaker, also known as sound, or the voltage coming across a cable, there will always be a position or a value between any two given points in time. Therefore, signals in real life are continuous, or in the case of sound we also speak of analog. Now imagine sound hitting a microphone. The microphone converts this continuous signal of sound into a continuous signal of voltage. This voltage travels along the cable to the mic preamp, and the preamp has a very difficult job to do. The preamp has to convert this continuous signal of voltage into a format that the computer can understand. Computers are part of the digital domain, so these preamps are also sometimes called analog to digital converters. So what does digital actually mean? Well, digital means a lot of things, but in this case we will focus on the fact that computers cannot save continuous signals. Computers basically consist of a bunch of switches that can either be turned on or off. So the switches are, put simply, the limit to where you are able to zoom into. You cannot say what state a switch is in that is between two neighboring switches, because there's simply no switch between two neighboring ones. So inevitably we are going to lose some information when converting an analog signal to a digital one. That's unfortunate. But if we are able to lose so little information that we are not even able to perceive the loss anymore, then we should be fine, right? Actually, it's the same for videos. Cameras, which are the analog to digital converters in this case, convert the continuous stream of light that comes into the lenses into singular frames. And the camera does so in a particular frame rate. And at a certain frame rate, like for example 24 or 30 or 60 frames per second, we won't notice any choppiness anymore. For sound, we do the exact same. We capture only singular values at very little time intervals so that we won't notice the information loss anymore. This is called sampling. We sample a continuous signal at very little time intervals called the sampling period. The inverse of that is called the sampling frequency. So now our signal consists of a bunch of values, each recorded at singular points in time. Now our signal is called discrete, as opposed to continuous. Now it's called discrete, of course. This is also where the D of the DFT comes from. The discrete Fourier transform works with discrete signals. Actually, there are other similar kinds of Fourier transforms that work with other signals, continuous signals, but that's another topic for another time. But wait, frequencies in general are a way of telling how often a particular event happens in a specific time. For example, the sampling frequency says how often the event of sampling happens within 1 second. Often when we talk about frequencies in audio, we talk about a different event that we are counting. We talk about the period of a sine wave within a particular time. Why a sine wave? Well, sound is basically the periodic motion of particles, most of the time air particles, and the simplest periodic motion is a sine wave. You might think to yourself, why don't we simply measure the period of the sine wave and then we should know what frequency is in our signal, right? Well, it's not as easy, unfortunately, because imagine now multiple sines are layered on top of each other. Now it's not as easy anymore to measure the period of the individual sine waves, right? Well, the DFT is there to solve this exact problem. Okay, that's it for this video. The playlist of the series is linked down below. In the next episode we will actually be looking at layering different signals on top of each other and also at multiplying these signals. We will also be using the announced software. So have a nice day. Bye.